Alright, now let us try to find out the force for the normal force P and the reaction force Q. Okay, so let us find out these two forces. Okay, so let us apply these total Fx equal to 0, total Fy equal to 0, and total torque equal to 0, and then we surely can find out the forces required. Okay, so we start with total Fx equal to 0. Okay, let's build the equations. Alright. Okay, so here, okay, I start off with total Fx equal to 0. Okay, so what are the forces involved? We have these, so we just total up all these forces, we get 0. Okay, so we have Rxq. Okay, Rxq, and then we have this negative normal force. Okay, negative normal force P equal to 0. Okay, and then one thing is we should know that this okay, back to here. So this is our free body diagram. All right. So one thing we should know about this Rxq, this is actually the friction. So maybe we can change back this to friction. This is actually the friction. Okay, call it the static friction. And then Ryq is the normal force. Okay, the normal force for Q. Okay, so maybe it's good that we relabel this one. This Rxq is actually the friction also. It is actually the friction on the floor, where the static friction, whereas the Ryq is the normal force. Yeah, normal force on Q. So relabel it. This is the normal force on Q. Yeah. Okay. That's the one lah. Okay. Right. Relabel it. Okay, it might be helpful. Okay, so we can write this one. Okay, this one, this Rxq is actually the friction. Okay, it's actually the friction. Friction minus the normal force. So from here we can see the normal for the friction is actually the normal force at P. Okay, but we don't have either one, isn't it? So is still unknown, so we need to continue to total Fy equal to 0. Okay, so we use total Fy equal to 0, another formula here. So just total this up. Okay, we have the this reaction force Ryq, just put it as Ryq, negative weight equal to 0. Okay, then this Ryq is actually the normal force on Q. Is actually the normal force on Q. Which is equal to the weight. The weight is equal to mg. Okay, but however, I see the question give you the weight already. It give you the weight 240 Newton. 240 Newton. So we can actually just substitute this one as 240 Newton. Yeah. Sorry, need to put the negative sign. Yeah, negative 240 Newton. Because it give you the weight. Yeah, 240. All right. So okay. So let's continue. So the normal yeah. So no need to write mg anymore because we already have the weight. So the normal force for Q is actually 240. It's actually 240 Newton. We already got the normal force for Q. Okay, we already got the normal force for Q. So, and then the friction here. Look at the friction here. The friction here is actually friction on the Q, isn't it? This is actually friction on Q. Friction on Q, right? This is the friction. The Rxq. the Rxq is actually friction on Q. Just label this as a friction on Q. Okay, it's better, right? More complete. Yeah, it's actually friction on Q. Okay. So okay, this Rxq is actually friction on Q. All right. Okay. So we got the another relationship here. So this friction on Q, it give you the mu already, isn't it? It give you the coefficient mu s. Between the beam and the floor, it give you the mu s of the floor. So we can use mu sn. We can use mu sn. Yeah. So Fs equal to mu s n. This one use normal force of what? The friction on Q is dependent on normal force of Q, isn't it? Which is the Ryq. So this one is the mu s and on Q. Okay. So which is also equal to normal force for P. Okay. Now mu s given is 0.25. Okay, 0.25. Okay, just write it down, 0.25. And then what's the NQ? NQ, 240. Just now we found from total of Fy equal to 0 is 240 over here. From here we can find the normal force for P. Normal force for P. Okay. So let's calculate out what is the normal force for P. I got is 60. Normal force for P is 60 Newton. Okay. So I got the normal force for Q and also normal force for P already. Normal force for P is 60 Newton. Anyway, normal force for Q is also the Ryq lah. Okay, it's also the Ryq. Alright, just want to take note. Yeah. Normal force for P. What else we don't have? Yeah, we don't have the Rxq, which is the friction, isn't it? Actually, here we can also find the friction. We already found the friction also, right? From that part just now, we already got the friction also from here, right? Okay, write it down. So the friction on Q, which is also called the Rxq. Yeah, which is also called the Rxq. Okay, Rxq is mu s n. But this one mu use the normal force on Q, right? Yeah. So we also actually got that already. Yeah, we also got the friction already. So just now, what do we get? Yeah, what do we get? Yeah, actually the friction is the normal force for P. Yeah. This is actually the okay. Yeah, we see that. Yeah, it's actually the same. Oh, sorry. It's actually the same as the normal force for P, the friction. Yeah. Okay. It's actually the 60 Newton. Yeah, sorry. 60 Newton. Yeah, which is also the normal force for P. So the friction Q, the friction Q here is actually the normal force for P also. Yeah, which is 60 Newton. 60 Newton. Okay. So okay, let's write down all the information we have over here. Let's transfer it. Okay. So from okay. Yeah. Okay. So what's the answer for the forces acting on P and Q? Okay. So we got the answer already. Yeah, we got the answer already. So first of all, look at this diagram again. So the question 3 just now we got the normal force for P. We got from calculation there. It is 60 Newton. 60 Newton. And then for the reaction the reaction x for Q is also the reaction x for Q reaction x for Q is actually the friction. Okay, is actually the reaction x for Q is actually also the friction for, yeah, is also actually the friction. Is also, we found out the friction is also the normal force for P, yeah, normal force for P. So this also 60 Newton. And then another last thing is the normal force for Q. Normal force for Q, we got it is equal to the weight. It is 240 Newton. Okay. So this anyway, this is the, okay, I want to write it better, yeah, in better way. This actually here, this is the RYQ lah. Okay, RYQ is the normal force for Q, yeah, which is 240 Newton. Okay, so but for point Q, you need to find the resultant, not just the Rx and Ry. You need to find the resultant. So that means you need to find the resultant. Okay, so these two, okay, we can find the Rx already. Yeah, no, we can find the Rq. Okay, use the Pythagoras theorem. So Rq is equal to the square root Rx Q square plus Ryq square. Okay, so which is also 60 square plus 240 square. So what's the answer? I got the answer is 247.39 Newton. Okay, so that's the answer. That's the force on P and force on Q. Okay, force on P and force on Q. Is the answer correct? Oh, one more thing, you need to find the angle theta. The angle theta, but it's not the theta for the beam, it's the theta for the RQ. Okay, you need to find the direction also. So let's find out the direction. To find the angle, you understand what I'm saying? What I'm trying to say is this one. See this one? Yeah. Okay. So you need to find the angle theta for RQ, not the theta for the beam. Okay, let me sorry. Okay, hold on a second. What I mean is this one. Okay, we have to find the theta. You know, because this is a vector. Reaction force is a vector. You cannot just give magnitude. You need to give direction also. So you need to mention the theta also, the direction. Okay, so find the theta here, not the theta for the beam. It's the theta for the reaction force. Okay, so use tangent theta. Use Ry over Rx. Use Ry over Rx. So Ry is what is the Ry? Ryq is 240. Yeah, this Ryq divided by the Rxq. Yeah. So 240 divided by 60. 240 over 60. So and then we anti-tangent. Don't forget to anti-tangent. So let's find out. Yeah, what's the answer? Okay. So the answer is 75.96 degree above positive x-axis. So that's the answer. That's the answer. Okay. Okay. So the answer, so this is the direction. Okay. This is the direction for RQ. Direction for RQ, and then direction for NP also you need to mention there. You must say to the left. To the left. Say its normal force is to the left. Okay, because it's a vector. Vector, you need to give the magnitude and direction, not just the magnitude force only. You need to give the direction also. So normal force is 60 Newton, direction to the left, and then reaction force for Q, the reaction force for Q is 247.39 Newton, and direction is 75.96 degree above the positive x-axis. Okay, that's the direction. So is it correct? Let's check the answer. The answer is yeah, normal force for P is 60 Newton to the left. 60 Newton to the left. Is it correct? Yes, correct. Okay, 60 Newton to the left. And then what about the force on Q? Force on Q is 247 Newton. Is it correct? 247 Newton? Yes, RQ is 247 Newton. That's correct. How about the direction for RQ? Direction for RQ is 76 degree above positive x. 76 above positive x. 76 above. 75.96. Yeah, near to 76 above positive x. That's correct. You must give magnitude and direction also. Yeah. Okay, solved. And then now next look to determine the theta minimum. Okay. So how to find the theta minimum? So theta minimum is the beam. This theta minimum is not the theta for the reaction force. Theta for reaction force is different from theta minimum. Theta minimum is for the beam. This theta is for the reaction force. Okay. So what I need to find theta minimum here is for the beam. Yeah. For the following questions. Theta minimum. So this one, I think you need to use the torque already, because the torque here use the theta for the beam. Okay, because the torque. Remember this one? Just now you do about the torque. Okay, this theta, the purple theta here, this theta here is the same as the theta minimum. It's the same as the theta minimum, which is the theta for the beam. Not the theta for the reaction force. It's the theta for the beam. So this theta and this theta here, you are used in over here. You are used in over here. Okay. This is the theta for the beam. So this one you need to do the torque. Okay. So we need to use the third formula. Okay. For this one. Okay. So the third formula is the total torque equal to 0. Total torque equal to 0. Okay. So for this one, we also total up all these torque. Okay, total up all of them. So we have negative W. Okay, just write it down. Negative W cosine. We need to find the theta here, and then L over 2. Okay, and then plus this one. Yeah, plus. Just bracket everything just in case we need to find the theta there. Yeah? You find the theta there, and then L equal to 0. Okay. So you see this one can go to the other side, so it become what it becomes. Yeah. Oh, this is actually the normal force on P. Yeah, normal force on P. Okay. So okay, write down. So this is normal force on P sine theta times L. Okay, times L equal to, this is the weight cosine theta. This L over 2. Haha, I see the L can be cancelled off. It can be cancelled off. L can be cancelled off. You see that? Okay. So the negative disappear already when go to the other side. Okay. And then theta don't cancel. This cos theta need to go below here, become sine over cos, then become tangent theta. Then we can find the theta. Normal force for P, just now we got it. Normal force for P is 60 Newton. 60 Newton. 60 Newton sine theta equal to weight also given. Weight also given is 240 Newton, isn't it? 240 Newton. Oh, it is so easy to do. And then here we still have half. Don't forget the half. Okay. So okay. Then divide by 2. This one cancel them. This one become 120. Okay. So what do we get? Yeah. Okay. 120, and then cosine theta go below here. it becomes sine theta over cosine theta, and then equal to, and then this one is 120 over 60. This 60 go below here. So sine over cos, we get tangent theta. Tangent theta equal to 2. So what is the theta? What is the theta? Let's calculate. Antitangent 2 equal to 63.43. This is the degree. Okay. This is for the beam, the minimum, and this is for the beam, the angle for the beam. Okay. Is it correct? Is the answer correct? Let's find out. Yeah, let's check the answer. Is the answer correct? 63.43. 63.43. Yeah, 63.4. Jackpot. 63.4. 63.4. That's correct. That's correct. Okay, 63.4. That's the angle for the beam. That's correct. Okay. So, can you see it's different angle? Can you see the angle is different? This angle theta, this is for the reaction force. This theta just now is for the reaction force on Q. This theta is the beam, the angle for the beam. They looks like at the same place, but they are actually different angle. This is angle for the reaction force. This is the angle for the beam. So it's different value. You see that? And I got them. I got the value already. You see? See, I got the value already. Okay, so happy. Now let's continue. Yeah, this angle is for the reaction force. Yeah, this is for the reaction force. This is for the beam. Okay, so what will happen? Okay, what will happen to the beam if the inclination angle is changed? Consider both cases. Yeah, if the new angle is less than the minimum, and okay, what will happen to the beam if the inclination angle is changed? Let's think. Okay, what will happen to the beam? Yeah, if the angle theta minimum is changed. Okay, if the new angle is less than theta minimum, or the new angle is more than the theta minimum. Okay, but the theta must be less than 90 degree. Okay, so what will happen to the beam? Okay, so just as you learned about friction before, it's all because of the friction here. Okay, so for this question, for question 5, see, he already mentioned this is the theta minimum. What is it really mean by theta minimum? Just now what you get the theta minimum, what's the value? What's the value we get the theta minimum? Your value you get is 63.43 degree. That's the minimum angle for the beam. Okay, that's a 63.43 degree. This is for the angle for the beam. Why you have a word minimum there? The answer is minimum. So why you have an angle minimum here? How do we find the angle minimum here? We found the angle minimum here is when we apply the maximum friction. We apply this Fs equal to mu Sn. You see that? We use Fs equal to mu Sn. So to find the angle minimum, yeah, Fs equal to mu Sn. So theta minimum is when, what we can say about theta minimum is when the Fs achieve the maximum static friction, which is using mu S and Q, because this is for the floor, isn't it? This friction is for the floor. Okay, this is for the floor, so that's why you use the normal force for Q, not the normal force for P. Yeah? Okay, so it achieved the maximum static friction already. Mu S and Q. Okay, which is what value is the static friction? Maximum static friction we get? We get the maximum static friction is equal to 10 60 Newton. Yeah, the friction is 60 Newton. US and Q, we get 60 Newton. 60 Newton. Okay, get 60 Newton. Okay, achieve maximum already. The static friction achieve maximum already. So, if you change the angle, let's say the new angle, okay, the new angle is more than the theta minimum, then it's safe. It is safe. Yeah, that means it is safe. That means the beam won't fall. Okay, this is the first condition. If the theta is more than the theta minimum, it is safe. But if you less than the minimum, it already mentioned it is minimum. It's minimum. So if you less than the minimum, surely the beam will fall. Yeah, if the theta minimum, excuse me, if the new angle is less than the minimum, the beam will fall. Not safe. It will lose the equilibrium. Okay. So, right. Yeah, I rewrite it. So if you more than the minimum angle, it is safe. The beam will not fall. But if the new angle is less than the theta minimum, the beam will fall. It's not safe. Because if you less than the minimum angle, the friction needed is more than the maximum static friction. But the floor cannot provide more than that. It can only provide 60 Newton. If you less than the minimum angle, your friction needed will be more than 60 Newton. Certainly the beam will fall. So maybe I can redraw for you and see. This is what it means. I draw for you. If like this, surely is safe because the angle is more than the minimum angle. So the beam will not fall. Yeah, the beam will not fall. But if you less than the minimum required, like this, it will lose balance. This one will lose balance. Okay, it will lose balance and the beam will fall because the floor cannot provide more. Yeah, cannot provide more friction. The maximum friction it can provide is only 60 Newton. But if you put your beam like that, yeah, it almost tend to fall already because the friction required will be more than 60 Newton. But your floor cannot provide more than 60. But the friction needed for this kind of position, you need more friction than 60 Newton. But the floor cannot provide more than 60. That's the maximum static friction the floor can provide. So the beam will fall. Yeah, if your new angle is less than the theta minimum, less than this 63.43. Well, we can say if the new angle is less than 63.43, yeah, maybe this new angle is only like, let's say 30 degree, only 30 degree will fall. The beam will fall, lose balance. If the new angle is, let's say 70 degree, it's safe. Okay, it is safe. It will not fall. Yeah, it will not fall. But if like this 30 degree, or let's say 40 degree or 50 degree, 50 degree also will fall. Okay, so that's the answer for the last questions. Yeah, what will happen to the beam if the angle is changed? Okay, so that's all for this explanation. Yeah, I hope you understand what I'm trying to say. Okay, these are the answer. Yeah, maybe I have let you have a glimpse. Yeah, I need you to copy all the answer. Yeah, so hopefully you can copy the calculations. Yeah, and that's all for this video. Okay, thank you for watching. Yeah, this is the answer. All right, thank you for watching.